We have two functions that are a little bit more complicated than the first one. F of x is a rational function and g of x is a parabola. We want to determine an explicit equation for the composite functions. And so you're going to notice the same thing that we sort of listed here. This strategy of finding the explicit equation is going to help us with our composite functions. So here we want to find g of f of x. Okay? And here we want to find f of g of x. Again, I'm going to give you some time to try it on your own first. Check with your neighbor, and we'll see how we're doing. So just find the explicit equation. We'll do the domain together after. So first of all, f of x is 1 over x plus 3. And g of 1 over x plus 3, well, whatever you put into g gets squared, and then you minus 4 times that. So if you put in 1 over x plus 3, that 1 over x plus 3 is going to get squared, and then you minus 4 times that 1 over x plus 3. So this would be what it would look like unsimplified. And I didn't ask you to simplify it, so if you left it like this would be fine. Now, walking around and seeing some of the simplification, I want to point out one thing is when you would simplify this, on this side, when you square this, you're going to get 1 over x plus 3 squared. And when you square x plus 3, remember that you would have to distribute. You're going to get x squared plus 6x plus 9. I saw a lot of x squareds plus 9s. Okay, so if you're making that mistake, that's a good thing to see right now. If you're multiplying this one, this will be 4 over x plus 3. If this was an exam and they wanted you to simplify this completely, you would have to get a common denominator and write it as a single fraction. Okay? But we're going to leave this right now, not simplify it any further. For the second one, f of g of x. Well, g of x is x squared minus 4x. And f of x says whatever you put in, you do 1 over that value and add 3. So this will equal 1 over x squared minus 4x plus 3. Now, we're just looking at domain because these graphs are not pretty graphs. You'd have to use your graphing calculator to play around with them a little bit. But when looking at the domain of your explicit equation, have to ask yourself, is there anything that's not allowed? Well, here you might divide by 0, right? So what can't x be? X cannot be negative 3. And not only do you have to check your final equation that you get, but you need to check all the way through. Like here we're dividing, but here it's x equals minus 3 again. Here it's x equals minus 3 again. Here we're dividing, it's x equals minus 3 again. So the domain is everything except x can't equal negative 3. For the second one, we're not dividing here yet. In our final equation, we are dividing. In fact, I could write this final equation in factored form, which might help us a little bit. It's x minus 3, x plus 1, x minus 3, x minus 1. Because there's a quadratic on the bottom. The bottom is x squared minus 4x plus 3. And we would need to factor that. So looking at our explicit equation, now we have two non-permissible values. In this one, x can't equal 3. X can't equal 1. If we check earlier, back to this first step, this has no dividing. So far, everything is good. At this point, the domain is everything, but later on, we do divide. So you're checking everywhere in your equation for non-permissible values. Sometimes non-permissible values go away, like in the situation where you have a hole, but it's still a non-permissible value. So there's our domain for that one. Questions for this one, and we're actually going to do it together. is 6d. So we'll just go So I'll give you a head start on it. Check with your neighbor again. F of x. So f of x would be equal to the inside f of x is 1 over x minus 1. And the function f says whatever you plug in, you put that 1 over that minus 1 after. So this will be 1 over, and then you'd have 1 over x minus 1 would get put in, and then you subtract 1 after that. So now we need to simplify this equation. What do you do when you have fractions inside of fractions? We did a lot of this in identities. We want to get a single fraction on the top, which it is already, 1 over 1. And we want to get a single fraction on the bottom, which it isn't. So we'll need a common denominator. Does it make sense that I'll have to multiply this one by x minus 1 and x minus 1 to get a common denominator? And then I will get 1 over 1 over 1 minus x plus 1. Simplifying that becomes 2 minus x over x minus 1. Now that we've got a fraction divided by a fraction, how do you write that as a single fraction? Multiply it by the reciprocal. So you're going to get 1 over 1 times by So there we have our simplified version. What is our domain? And this is why I wanted to do this one together. Do we have any non-permissible values?
Negative 2.
X can't equal 2. Is that the only non-permissible value?
No. X can equal 1.
Now, x can't equal 1, not because of the x minus 1 on the top of the fraction. That's okay, but we have to check every place that we're dividing in our entire work. And here we're dividing by an x minus 1. Here we're dividing by an x minus 1. Even here we're dividing by an x minus 1. And in fact, even initially, we were dividing by an x minus 1. And so because that was in our work, if you plugged in 1, somewhere along the way, you'd hit a non-permissible value. So we have that as well as a non-permissible value. And that's why I wanted to do that one together.